Hi, welcome back to Mahiti Dunia YouTube channel, my dear friends. So in this video, we are going to see NPTL course, that is Deep Learning Assignment Answers, assignment number 8 answers. We'll see one by one. So here you will get the explanation for all the answers. So stay tuned. First one, which of the following is false about convolution neural network? The first one is output should be flattened before feeding it to fully connected layer. There can be only one fully connected layer in the CNN, and we can use as many convolution layers in CNN. So if you look at the first one, output should be flattened before feeding it to the fully connected layer is true, and we can use as many number of convolution layers in CNN, that is also true. But look at, there can be only one full connected, so there can be only one fully connected layer in the CNN is the false one, that is wrong one. So in CNN we can have the multiple fully connected layers. So there can be one only fully connected layer is the false statement. So we'll go to the second one. The input image converted into matrix of size 64 into 64 and kernel size of 5 cross 5 with a stride of 1 and no padding, what will be the size of convolution matrix? So carefully go through this problem, so that we'll have many questions based on this, so that can they have given 4 answer, the answer is 60 cross 60 is correct. How we can see this explanation? That is formula we are having, that is input size minus filter size into 2 into padding divided by stride, the plus 1, you can look at the plus 1 is here. Then after that, input size, what is the input size is given 64, what is the filter size is given 5, what is the stride 1, padding 0. So the output size is equals to, what is the input size 64, filter size 5, so 2, padding is 0, no padding is given. So the if you do the calculation, you will get here 60. So the size of the convolution matrix is 60 cross 60, that's why 60 cross 60 is the correct answer. So we'll go to the third question. So the third question is, filter size 3 cross 3 is convoluted with the matrix size of 4 cross 4. Stride 1. What is the size of output matrix if valid padding is applied? So 4 answer is given. So the correct answer is 2 cross 2. So we'll see the explanation of this 2 cross 2. So input size is 4 from the given problem, filter size is 3, stride is 1, valid padding is 0. So same apply the formula. So input minus filter size, padding is 0, so we are not considered here, stride plus 1. So apply 4 minus 3 and you are getting 2. So size of the output matrix will be 2 cross 2. Okay. So fourth question, so it is similarly we are having, the question is looking like the bigger, but the answer is simple. So can consider the CNN having the 3 different convolution layers with its architecture as 3 layer is given. Layer 1 consists of filter size 3 cross 3, number of filters 10, stride 1, padding 0. Layer 2 consisting of filter size 5 cross 5, number of filters 20, stride 2, padding 0. Layer 3 consisting of filter size 5 cross 5, number of filters 40, stride 2, padding 0. So here the layer 3, that is the last layer of above network, is followed by fully connected layer. So we have the 3D image input dimension 39 cross 39 to network. Which of the following is input dimension of fully connected layer? So answer is 1960 to 2200. So out of this, the correct answer is 1960. How? Explanation we'll see. So layer by layer we'll go. First layer. For the first layer, look at this, input is given 39 into 39, that is input. Filter size. For the first layer, what is the filter size? 3 cross 3. Okay. So what is the number of filters for the first layer? 10. So what is the stride? 1. So we'll write all those things, then apply the formula, same formula. Output size equal to input size minus filter size divided by stride plus 1. So it is 39 minus 3 here. Then if you do this, the output size is 37 you will get. So from the first layer, output dimension will be 37 cross 37 into 40. Sorry, 10. What is the 10? 10 is, that is in the layer number 1, the filters are, number of filters are 10, so that 10 you should consider. So the layer 1 output dimension is 37 cross 37 into 10. So similarly, we can see for the layer number 2. So in the layer number 2, the input size we will see. One second. So in the layer 2 input size, so now the layer 1 output is 37 into 37 into 10. So that is considered as the input to the layer 2. So 37 into 37 into 10. Then filter size is 5 cross 5, because for the layer 2 it is given as you can observe here for the layer 2 you are given as filter size 5 cross 5, number of filters 20, stride 2. So here the number of filters 20 and stride 2, padding is 0. So the output size is equals to input size minus filter size. So what is the input? 37, filter is 5. So subtract and do this, 17 you will get. So the output dimensions now become 17 cross 17 into 20. Why 20? Because it consisting of the number of filters 20. So here this is the output of layer 2. Similarly we are having a layer 3. So this is considered as the input to the next one. What is input to the next one here? Look at this here. We are considering input size 17 cross 17 into 20. Why 20? So this is what the filter number is. So now for this layer 3, consider the formula same, 17 minus 5, same thing you will get 7 you will get. So once you got 7, so it is 7 cross 7 into 40. 40 is a filter number. So this is the output dimension. So this output, so in the question you can observe the layer 3 of the above network is followed by fully connected layer. Okay. So if you give this 3D image, so okay, which of the following is input dimension? So we should feed whatever we are getting here, this to the output. So multiply all this, so we are going to get 1960. So the correct answer is 1960 what we have considered. Okay. So go to the next one, that is fifth question. 40 convolution kernel size 3 cross 3 with no padding and stride 1 in its first layer of the CNN. The input of the dimension 1024 into 1024 into 3 through this layer. What are the dimension of the data which is next layer will receive? Okay, so input size, what is that? It is 1024 into 3. Filter size is 3 cross 3. Number of filters is 40 and stride is 1 and dimension padding is 0. So apply the same formula, input size minus filter size divided by stride, 1024 minus 3 divided by 1 plus 1, so 1022 you will get. So the output dimension is 1022 into 1022 into 40. 40 is the number of filters. Okay, kernel size. So this is the fifth question answer explanation. So what is the sixth question? Consider the CNN model of classifying image as either a rose or a marigold or a lily or orchid. So the last layer of the CNN output is a vector of logits L that is passed through a dash activation function that transforms logits into probabilities P. So these probabilities are model predictions of each of the four classes. So here four different classes are given, that is rose, marigold, lily or orchid. The four different of flowers they have given. So to classify this we are going to use what type of function? Softmax activation function. So this function is commonly used for the multi-class classification problem. So four different class are given, so for this we should use the softmax function. So that is the explanation for the sixth. So seventh one, suppose your input is 300 by 300 color RGB image. So you use the convolution layer with 100 filters that are each 5 cross 5. How many parameters does this hidden layer have without bias? So 4 answer is given. So out of this you can just look at the number of filters in the given problem is the 100. You can just look at this. Next, the filter size. Then the filter size is 5 cross 5. Input channel is, you can observe RGB. So it is 3. So the number of parameters is calculated by the number of filters into number filter height, filter width and input channels. So the number of filters are 100. So filter height and width both are same, 5 cross 5, 5 into 5 into input channel is 3, RGB stand for 3. So if I multiply this, so I am going to get the answer 7500. So the answer is 7500. Okay. So eighth question. What is eighth question? Which of the following activation function can lead to vanishing gradients? So sigmoid is a function which leads to vanishing gradients. So statement 1, ninth question. Residual networks can be solution for the vanishing gradient problem. Statement 2. Residual networks provide a residual connection straight to the earlier layers. Statement 3. Residual networks can never be solution for vanishing gradient problem. So these three statements are given. Statement 2 is correct, 3 is correct, both are correct. Statement 2 and statement 3 are correct. Here third option is statement 1 and 2 are correct. So out of this the answer is statement 1 and 2 both are correct. What is the one? Residual networks can be a solution for vanishing gradient problem and the residual networks provide a residual connection straight to earlier layers. This is correct. So third statement, residual networks can never be the solution for vanishing grain problem is a wrong one. So statement 3, this is wrong. B is and D is directly wrong. 2 is correct, but along with that 1 is correct. So statement C, that is answer C, is correct for the ninth one. So the 10th one, input to the softmax activation function is 0.5, 0.51. What will be the output? 4 answer is given. So this problem is already appeared in the 3, 4 or 5, 5th assignment. I'm not sure, but this problem is appeared already. So softmax function is equals to exponential of x divided by summation of exponential x. X value is given 0.5, 0.51. So you should find the exponential of this with the help of the online calculator. You should find this exponential of 0.5, exponential of 0.5, exponential of 1. So the answer is like this. So add all this, because the denominator is like this, add all this, so you will get this. So softmax function is going to be, so individual divided by total, individual divided by total, individual divided by total. So you will get approximately this answer, 0.274, 0.274, 0.452, but that answer is not there here. But the closest one is this one, 0.28 instead of 0.274. So 0.274, 0.28, and the last one is 0.45, here 0.44. So first one is the correct answer. So like this is the assignment number 8, answers for the NPTL, that is the subject deep learning. So like this we are going to upload the remaining assignments 9, 10, 11, 12. So we are going to upload all 1 to 12 assignments of NPTL course subjects assignment answers. Okay, so good luck for your examinations. Take if you are not followed, just I explained all the answers. It is not just obtaining the answer, not just knowing the answer, explaining with each and every bit. Okay, stay tuned to my YouTube channel. Click on the bell icon for the latest notifications. Thank you. Click on the bell icon for select all notifications. Click on bell icon and select all notifications. So immediately once I upload the video, you will get the videos. Thank you.